Hello and welcome to ISO Math. Today we're going to talk about shortcut derivatives using powers and polynomials. In this section, the first rule we're introduced is the derivative of sum and difference. It simply means if I have two functions and I'm trying to find the derivative of two functions, I can evaluate them individually. Or if they're separated by a plus sign or if they're separated by a minus sign. Something they can look like, such as something like if I had x squared plus x cubed, and I wanted to find the derivative of the two functions, I can evaluate them individually. All that simply means is I can evaluate the separated by the plus sign, I can evaluate them individually and find out my rule. Likewise, if they're separated by, if I need to find the derivative of two or more functions, say I had x to the fourth minus x to the fifth plus x to the third, same idea, I can evaluate them individually, and that's what the plus sum and difference rule simply means is if they're separated by a plus or minus sign, I can evaluate them individually and break them apart and do them individually, find out the derivative individually. Our next rule talks about theorem is basically the constant multiplier rule. In this case, if I had something such as 2 times x to the third, because I have this constant out in front, that's what that C represents right there, constant out in front, I can evaluate, this is nothing more, is I can pull this out, that constant, and evaluate the function as itself individually. Then after I evaluate the function of that x cubed, then I'm going to multiply the results by whatever results I get there. So that's what the constant multiplier rule tells me, is I can factor out any leading coefficient, and then after I evaluate that function, I'm going to distribute that coefficient back through. And now we're getting into the power rule. Now let's start with one of the most basic ones. Say if I had x to the third. Well, according to this rule, this takes on the form of x to the n, with my n in this case n equaling 3. So my results of this is I'm going to drop down that 3. That's going to become 3x, and then I drop my power degree down by 1, so I'm left with a final derivative of 3x squared. So the derivative of x cubed is 3x squared using the power rule. And now I can combine that with the constant multiplier rule. Remember, if I had similar, so if I had 2x to the third, now I have a combination of both rules. Of the constant multiplier rule, I can take that 2, factor that, or hold that out in a piece, and then I'm going to evaluate my x to the third, which we know is going to be 2 times, and then I'm left with that 3x squared after I did the evaluation. Multiply my 2 back in, and I'm left with 6x squared. So that's how I can utilize the constant multiplier rule with the power rule, and vice versa. If I have something separated, I can also incorporate the sum and difference rule. An example of the sum and difference rule would be here. If I want to find out the derivative of finding out this derivative, constant multiplier rule tells me that I can evaluate them individually. So whenever they're separated by a plus or a minus sign, I can evaluate the terms individually, and that's not a problem for that. And then obviously the derivative of x squared, the square root of x, I'm sorry. So what I'm going to do here is when I go through, I want to make sure here I know I can use a power rule. So I've identified this guy, that's going to be a power rule. That's going to be nothing more than 3x squared. So I'm going to drop down my 3, my n, subtract the 1 from the exponent, I'm going to leave with 3x squared. Here's an example right here of the constant multiplier rule. So I'm going to have 4, pull that out, times the derivative of x squared, which is 2x. And that's obviously going to be an 8x after I simplify everything out. Derivative of 3. Well, the derivative of a constant, derivative of any constant is 0. So that's just going to be left with 0. Now this guy, I have to change. Before I evaluate his derivative, I need to turn him into from radical form into exponential form. So that's nothing more than x to the 1/2, if you remember your rules of exponents. And now I'm going to use the power rule. The power rule tells me I'm going to drop the 1/2 out in front. So it's going to be 1/2, and then it's going to be x to the 1/2, which I start with minus 1. And obviously I got to convert that into like fractions up top. So this piece up here is nothing more than going to be 1/2 minus a 2 over 2, which gives me a negative 1/2. So I'm going to be left with the big 1/2 out in front as a leading coefficient, x raised to the negative 1/2. And I have my 0 here, which I know I can drop, 8x minus 3x squared. So that right there will be my derivative of the original function. So last but not least, let's try one. Now this guy, the mumbo jumbo. So again, before you start panicking, remember, yeah, it's a long term, but let's break it up. We know by the sum and difference rule, because of these plus signs and minus signs in here, that I can evaluate each term individually. So before I do that in panic mode, let's just break it down. I'm not going to be evaluating those guys. I also see some radicals here, so let's go ahead and rewrite a couple of these. Well, that's going to be 5x squared plus the 3x plus the 2. Let's rewrite this because I know I'm going to have to put that into exponential form, and that's nothing more than 3x to the 7th all raised to the 1/2 power, which we can distribute later. And this is nothing more. That's square root of 3. We can leave that square root of 3 out there. Why? Because that's a coefficient. I'm not worried about that guy. Because he's a coefficient, I don't have to be too concerned about him. And then this is nothing more than, if you really want to see it, 1/5 x to the 5th. 3 pi, that's an interesting, remember 3 pi, that is nothing more than a coefficient. That's 3 times pi. Pi is a number, 3.14. It's an irrational number, but ends up being a number. Minus e, well, e is also a number. 2 point, all the way through another irrational number, but it's nothing more than a constant. So once we identify that, let's go after the easy ones. We know that the derivative of any constant, here's 2, the derivative of that piece is going to be 0. We also know the derivative of this piece, 3 pi, is nothing more than 0, because 3 times pi is a number, and same thing, minus e. That's going to be the derivative of e is nothing more than 0. So those, when I find any of those derivatives, I've already taken care of some of the pieces. Here I use the constant multiplier rule, so I'm going to have 5 times. Then I'm going to use the power rule, so I'm going to drop down that 2 and subtract 2 minus 1 up top. And then obviously my 3x, derivative of 3x, because that has an invisible 1 up there, drop that down, that's going to be 3 times 1, and then when x raised to the 0 power, 3 to minus 1. So if I do this, it's going to be using the power rule, 3 times 1 times x 1 minus 1. Well, that's going to be 3 times 1 times x to the 0, and x to the 0, believe it or not, is nothing more than 1. So the derivative of that piece is nothing more than 3, and that's why we know if I have 3 to the x or any leading coefficient, the derivative of that piece is going to be 3. This guy, we're going to save it. We're going to come back to him, save him for last. But here I'm going to have, again, that's nothing more than the power rule with the coefficient out front, so I'm going to have square root of 3, and then I'm going to have 5 times x, then 5 minus 1 is going to be 4. And then this guy is going to be minus, bring the 5 out in front, so I got 1/5 times 5 x to the 4th. And I can simplify that, I know. Now this guy, 1/2. So I need to take the 1/2 to the 3, and I need to take the 1/2 to the 7. So this guy can actually be rewritten probably more efficiently as 3 to the 1/2, which is going to be our square root of 3, times x to the 7/2. So yes, I can basically, all I'm concerned about, that's going to be constant multiplier rule. So I'm going to bring that 7/2 down, subtract 1 from that guy, which is going to be 2 over 2, which is going to give me 5/2. And I still have that 3 to the 1/2, or square root of 3. So this guy simplified is going to be 7 times the square root of 3 over 2 times x to the 7, or 5/2. Oops, 5/2. Sorry about that. 5/2. So that is going to be my answer there. So I'm going to have plus 7 square root of 3 over 2 x to the 5/2. And back here we never finished that guy out. When I multiply him out, it's going to be 10 x to the 1st power. So my final answer of all that craziness is going to be nothing more than 10x plus 3. Obviously the 0 goes away, plus a 7 times square root of 3 over 2 times x to the 5/2, plus the square root of 3. I could put the 5 out in front technically. 5 times square root of 3 of x to the 4th, minus 5 over 5. That becomes nothing more than minus 1, or minus x to the 4th, and then my zeros. So that will be my final answer for my derivative of that nice little beast there. So I hope that helps, and remember, check back to ISOmath for all your math needs, and we'll hope to see you soon.